Hello, ladies and gentlemen, and welcome to this Hack in the Box Lockdown number 2 session titled Hacking the DevOps Butler, the Road from Nothing to Admin. In this talk, we will describe in detail the code analysis process that led us to discover the vulnerabilities that allowed us to hack into Jenkins and how we managed to exploit them to trip the Jenkins security switch off and gain control over the entire Jenkins infrastructure. Jenkins, for those of you who are not familiar with it, is an open source automation server used to accelerate the software delivery process. It is now widely considered the de facto standard in open source continuous integration tools. For many organizations, Jenkins effectively acts as the DevOps engine, addressing everything from source code management to delivering code to production. Okay, my name is Nimrod and I work for CyberArk Labs in Israel. In the past, I have been researching and developing embedded products. I was researching and developing for FPGAs. I was doing some web applications, some in-depth research on Linux containers. I'm also a licensed lawyer in Israel and again working for CyberArk. So now we're going to start with this slide about an example DevOps pipeline. I'm going to switch to the laser pointer here. Here on the left side, we have the dev part, and on the right is the ops. The general scheme here is the following. Developers located here are pushing code to the code repository, which is in turn notifying Jenkins about the new code using a webhook. Jenkins is brought to life and starts building the code here, testing it over there, and eventually pushing the code, in our example, as an image into the Docker Hub here. If the dev side compilation and tests are successful, Jenkins will be prompted to continue with the ops side. This here, on the ops side, Jenkins starts another process which instructs the Kubernetes cluster here on the right to fetch the Docker Hub image previously saved here in this stage and deploy it across multiple customer-facing AWS instances. Enterprise DevOps teams today have the ability to deliver high-quality products and services to market faster and more efficiently than ever before. That's in part made possible through the use of DevOps methodologies and tools such as Jenkins. And this was the main drive initially for this research. So we're going to start with a brief introduction to Jenkins. Here in front of us is a Shodan scan. Shodan is a search engine for internet-connected devices and is an extremely important tool for cyber attackers. So this scan shows that almost 80,000 Jenkins servers are accessible online. You can see it's the number here on the left. This is a large number of servers, and of course does not count all the Jenkins servers and infrastructure, which is located inside closed networks. We know attackers are constantly trying to obtain access to those Jenkins servers in order to take advantage of the unique blend of credentials and code execution available to Jenkins. Over the past months, we at CyberArk Labs have been extensively researching Jenkins as part of our ongoing DevOps research. Our research has now evolved into 6 CVEs and 5 blog posts on the subject. You are more than invited to read those research blog posts at CyberArk Labs Threat Research blog. Today, we're going to talk extensively about 2 of those vulnerabilities and what was the research process that we used to discover them. Now, Jenkins, as we said, is the de facto standard in open source continuous integration tools with more than 220,000 active installations around the world. We've seen that almost 80,000 of those are accessible online. Jenkins servers execute more than 200 million jobs on average per month, a staggering number indeed. Jenkins to date offers over 1,600 plugins. All of them are open source code and available for download from the Jenkins plugins website for almost every tool and customization around. Jenkins is used at the heart of the development stack of very large companies we all know, such as SpaceX, Facebook, ENC Square, eBay, NASA, Sony, Netflix, LinkedIn, Michelin, GitHub, Atmel, and even Nintendo. We all know Jenkins is a wonderful tool. It literally is the engine that drives the DevOps train uphill. We all love it when one tool solves all or almost all our problems. And Jenkins does just that. It clones the code right out of the GitHub the minute we make a change in our code and does everything needed to build, test, release, and even deploy to our customers, all while interfacing seamlessly with your favorite DevOps tools and applications. Jenkins is great at integrations too. Here we can see just some of the major plugin integrations Jenkins offers. From Git and Visual Studio source control repositories to Maven Art, Gradle, and Docker in the build and config part, Cucumber, JUnit, and Sonar in scanners and automatic testers, all the way to deploying artifacts to Docker Hub, AWS Cloud, and Kubernetes. Well, Jenkins has it all. It is therefore not surprising that Jenkins needs a lot of access to secrets to do its job. From usernames and passwords to GitHub, through access tokens to AWS and Kubernetes, SSH keys to access infrastructure, Jenkins holds them all, and so becomes a lucrative target for attackers, both from outside and inside the organization, seeking to take advantage of the unique blend of code execution and credentials, all available in Jenkins. It is these secrets that are increasingly sought after by attackers to carry out cybersecurity attacks, attacks which may result in complete takeover of an enterprise network. We will cover some of these attacks next. We will start with this case reported here, which is a high severity issue rated with a CVEs of 8.8. We'll explain how this vulnerability was identified using actual code samples. This vulnerability can be exploited when totally unauthenticated attackers manage to remove files from the Jenkins master file system, causing Jenkins to trip its main security switch, and in some cases, completely abandon all security safeguards, including those that are meant to protect the Jenkins infrastructure from data breaches. All of this allowing unauthenticated users admin access to Jenkins. As simple as that. This allows anyone to log into Jenkins as admin in what we called from nothing to admin. And although these issues were fixed a while ago, thousands of Jenkins servers are still vulnerable. Good, so now we begin our preliminary probing. I work at the labs of a privileged access management security software company, CyberArk. And part of our research is always geared towards looking into other software's privileged access. So we always begin our research on new software with looking into users' databases, for example, local databases, LDAP, Active Directory, and so on. And while doing this, we categorize all security measures the software under test is utilizing. Well, here in Jenkins, I actually don't mean to be disrespectful to Jenkins developers, but when we found this, we really laughed. Can any of you see what I mean here? Quite at the beginning of the probing phase of our research, we found, to our surprise, that Jenkins has this funny switch called Enable Security, which can be flipped on or off by the Jenkins admin. Well, it is only the admin that can do that, and the Jenkins admin is almost omnipotent. So this shouldn't be a problem, right? Well, as you can imagine, our goal from now on was one, to find a way to flip this switch and disable security for the entire Jenkins infrastructure, allowing any user on the network full admin access to the entire infrastructure. Let's see a short demo of that. So access to the global security configurations are allowed to Jenkins admins only. Here it is. Configure global security. But what happens on the Jenkins master when some admin decides to disable security? Let's have a look. Any sign of a login page simply vanishes, and we have complete access to all Jenkins pages and resources. Our next step in our probing was to find where this magical security switch is located on the file system. We hypothesized that Jenkins would be saving this valuable information somewhere inside the Jenkins home directory. Well, surprisingly, the first file on the Jenkins home folder is config.xml. Well, this might be it. But you can already see that there are a number of XML files in this folder. For example, Jenkins CLI XML and Node Monitors XML. Let's have a close look at what's inside the config.xml file. So this is a printout of the config.xml file, the Jenkins main config.xml file. And as you can see here on line 11, we have this switch, which is called use security. Well, our goal now is clear. We want to change this flag on the config.xml file from true to false. That's all. If we can accomplish that, we can launch the ultimate attack. An unauthenticated actor on the network would then gain admin access to the entire Jenkins infrastructure. That is going to be just great. But again, working for CyberArk, we are always interested in the user's database of any research project we have in front of us. And Jenkins was no exception. Looking at the Jenkins Global Security Configuration page, we can also choose the Jenkins Security Realm. This defines how Jenkins is treating its users and where their information is generally stored. In our case, we use the Jenkins own user database. Every new user of Jenkins, whether it is a user of Jenkins' own user database or of other user databases such as Active Directory, is welcomed with special gifts. A new directory is created for the username, and a new config XML file is written there with information regarding the new user, such as an encrypted API token, the user's email address, and its full name. The encrypted API token is a randomly generated token that may be used to make scripted clients, such as bots, impersonate the new user and invoke operations that require Jenkins authorizations, such as scheduling a build or changing a job script. For every new user, Jenkins prepares room on the disk to save the details of the new user. The term database is a bit misleading, as Jenkins saves the new user's information in that special directory called users, as we can see here. This is the users directory of our Jenkins. And we can see we have 4 users, 1 admin and user 1, 2, and 3. Every username is given a directory under Jenkins home users. And inside each directory, we will find a single config XML file. If Jenkins is set to use its own users database, this config XML file contains the hashed user's password, its encrypted API token, full name, email address, and more. Well, if we dive deeper into the admin directory, for example, we'll find the config XML of the admin. So we have a config XML file for each user under users username directory. Okay, this here in front of us is an example of a user's config XML file. We can see some of the information recorded here. Maybe the user's full name here, the API token, which is encrypted. This is the API token. The password hash here, its email address, and other information. Here, we have the Jenkins code that reads a config XML file into the Java code. So line 2 defines CFG as an XML file container, which is later on line 10 being directly unmarshaled here into a Jenkins class. So the file itself defines and builds the entire Java class. Unmarshalling in this case is loosely synonymous to deserialization in Java. Another nice feature Jenkins has is this script console. This fantastic console allows the admin of Jenkins to run code written in the groovy programming language on any of Jenkins agents and the Jenkins master itself, and also interfaces directly to the Jenkins Java code. This way, the admin can execute calls to functions within the Jenkins Java code, for example, for debug, or to run actual code inside the Jenkins source code. This is a very nice feature, and we'll be exploiting it soon. We're going back to Shodan for this slide here. Internet scanners are an important part of any probing activity. In many cases, the Jenkins people webpage is available for read-only users. So we had a chance during the probing to look into some of the Jenkins installation accessible on the internet. The people's page includes all the users which have access to this Jenkins installation or infrastructure. Well, here on this people's page, we can already see something suspicious. Some of the usernames look misplaced, as in this example that we see here. Root is not generally a Jenkins username. So this makes you wonder. We'll get back to this point later on. So right now we've finished our probing stage, and this is to summarize it. Well, point number one, we've seen how XML files are loaded directly from disk into Java classes in an unmarshalling fashion. So the XML file is read in its entirety and becomes a Java class. We've also learned that config XML files are used in multiple places across the Jenkins file system. These XML files are used to configure Jenkins Java classes. The main config XML file, and this is an important point, contains the security on-off switch of the entire Jenkins infrastructure under the use security tag. We've seen that. 4, each new user gets a new folder under a special username directory. And number 5, we've also encountered funny people behavior seen on our Shodan search, which we don't yet know how to exploit. Good. So now we're going back to some brief explanation about Jenkins logins. Every Jenkins user can log in using their username and password, and we've seen how that in one of the demos that we saw. And we can see it in this slide also. You have a place to type in your username and password. Another way of logging in is by using a machine consumable remote access API to almost all Jenkins functionalities. We're doing this by using a HTTP basic authentication with a user's API token. We came across the API token when we looked into the user's config XML file. The fact that every Jenkins user can authenticate using their password or by using an API token makes the authentication processes a little complicated and naturally requires a dual authentication mechanism. This dual authentication mechanism is implemented in a filter, a Java filter called Basic Authentication Filter. Why dual? Again, Jenkins supports two types of authentication. One is HTTP basic authentication, and the other is form-based authentication. The HTTP basic authentication is reserved for scripted clients. For example, as we said, bots impersonating human users to run scripts on Jenkins. while the form-based authentication is for humans to log in with the usernames and password, and this is done using the web user interface. Using the HTTP basic authentication, a client authenticates to the Jenkins master with a username and password or API token combination. In this basic authentication, the client's username and password or API token should be concatenated, base64 encoded, and passed in the authorization HTTP header, as we can see in front of us. The Jenkins master authenticates the user against a user's database in case of a username password combination, or by comparing tokens with the local user's API token stored in the user's config XML file in case of username API token authentication. So basically, we can issue an authorization request by using this curl CURL with authorization basic and this base64 username and password, and of course, the IP address of our Jenkins master. Okay, well, the next part is going to be a deep dive into the code. So again, this is our static code analysis, and we run this code that we see here by calling this curl, this CURL, this HTTP GET request. And again, just remember that we are not authenticated in any way, and we actually don't even know the password. So in the code, we've reached this basic authentication filter. And here, this basic authentication filter calls doFilter, as we can see here. And this authorization string is being filled up by the header authorization basic. This next command here that we see here, the descramble, takes the base64 that we see here and descrambles it or decodes it. And then we're looking for the colon, which separates the username and the password. And then we have the string username and another string for the password. Good. Now, the next stage here in the code is a call to get by ID or user get by ID. As we can see, only after get by ID returns, Jenkins calls to get the API token parameter here and checks if it matches the password that we supplied from our get HTTP request, from our CURL. So whatever happens before this compare here is completely pre-authenticated. Okay, so again, we call user get by ID with our username and another second parameter, which is true. This true parameter is quite interesting, and we'll return to it shortly. So, get by ID is called and continues by calling get or create. You can now notice that our interesting true parameter is now called create here. So get or create calls another get or create function, And here it adds another interesting parameter, return from get unsanitized legacy config file for the ID, which is the username. This is where everything gets really interesting. It seems that there was some Jenkins legacy file system that was used to populate the user's database. Digging in, we found two sister functions relating to this legacy database. So we have this get unsanitized legacy config file for which calls legacy file name of, and this legacy file name of simply returns the ID. Again, the ID is the username in lowercase. So whatever username we supplied via our curl, our CURL, this simply returns as lowercase. No sanitation at all. Good. So this would return Jenkins home and users and whatever username we have in lowercase. And it is appended by config XML. Let's have a look at our get or create. So here we are getting config file now for the ID. The ID is the username. This would return the sanitized version of our username. Again, it would be Jenkins home users sanitized username config XML. Let's have a look at what this sanitization is. So here we can see that if we supplied a username which has con, prn, aux, or a null, then this function would replace those with something less dangerous. Okay, back to get or create. Now this gets a little tricky here. So we now reach the get or create sister function with the last parameter being the unsanitized config file. This is where things get really interesting. When an unsanitized legacy file exists and the legacy configuration file is not equal to the sanitized configuration file, we move inside this if clause. The next if statement states that when the sanitized configuration file does not exist on disk, Jenkins goes further to create a new sanitized directory for the user, and the unsanitized legacy config file is moved into the newly created directory. Moving the file explicitly means that the file is copied into a new directory and then deleted from the original directory. Again, this looks like some kind of user directory migration procedure that is executed before any kind of user authentication has been performed. This sounds pretty dangerous. Can we exploit this logic? Knowing that we have a config XML file in the Jenkins home directory that contains the Jenkins main security switch, we set out to check the code and see if we can somehow convince Jenkins to remove the main configuration file from disk. All right, let's look into this flowchart and then analyze the code. We begin as an unauthenticated actor on the network and send an HTTP GET with simple authorization header with username, password. Our first checkpoint is testing whether the unsanitized config file exists. If there is no unsanitized config file on disk, then we simply do nothing. However, if an unsanitized config file does exist on disk, we move to the second checkpoint, here. Jenkins compares the unsanitized config file class to the sanitized one. If they are not the same, that is, not having the same file name, then we move to the third checkpoint, over here. Here, Jenkins simply checks if the sanitized config file exists or not. If it does not exist, then Jenkins will perform the migration procedure we saw earlier, which will move the unsanitized config file to a new sanitized location. Let us check the flowchart with the username ... To do that, we prepare a base64 string in the format username colon password that contains the username ... and any password we would like. Next, we send it using CURL. So again, we use authorization basic as a header. Jenkins code will compute the unsanitized config file to be Jenkins home users .config.xml, which is actually equivalent to Jenkins home config.xml. We know this file exists, as this is the Jenkins main configuration file we discussed earlier. So we've successfully passed checkpoint number 1. Jenkins does not allow the sanitized config file to have a ... in the username due to path traversal issues. So Jenkins replaces each dot with a string $002E. Therefore, the sanitized configuration file is computed as Jenkins home users $002E twice / config.xml. Obviously, the sanitized configuration file is not equal to the unsanitized one. We just passed checkpoint number 2. The third and last checkpoint checks if the sanitized file exists. Well, I don't suppose some Jenkins installation will have a user by the name of $002E, $002E. Well, we just passed test number 3. At this point, the Jenkins main configuration file, config.xml, the one that contains statements about the main security switch, has been removed by Jenkins itself from the Jenkins home directory. Note that Jenkins did not require us to authenticate to get to this point. This means that any unauthenticated actor with access to the Jenkins master can delete the Jenkins main configuration file and eventually, as we'll see next, gain admin access to Jenkins resources, secrets, and infrastructure. Well, I guess now is the right time for a demo. So we're first going to check and see if security is enabled or not. So logging in and clicking Manage Jenkins and then Configure Global Security, and great. The security is enabled. Good, we're now going to log out of our admin user and jump over to a bash shell. Here we are. Jenkins 121 is our Jenkins home directory. So we're changing into there, and the first file appears to be the main config XML file. Well, this is great. Next, we prepare the username password pair in base 64 for the HTTP GET request. So we're going to use ... and, well, any password, of course. In base 64, ... is the username, and don't have a password is the password. And next we're going to curl it with authorization basic header all the way to the Jenkins master. Now remember, we are not logged in any way. We're going to add the username password, base 64, and the IP of our Jenkins master. Okay, that's it. Once we press enter here, a GET request will be sent to the Jenkins master, and the process we've just shown would be executed. As we can see, we've got an error. Funny enough, this is rather a good sign. Good, let's go back to the Jenkins home directory and check there. As you can see, the config XML file just vanished. Well, but where did it go? So we can check the users directory, which holds all Jenkins users, and it seems that we have a new user called this funny $002e, $002e directory, and we want to look inside. So we're changing into the directory, and inside we have a config XML, which is, quite interestingly, the original Jenkins home config XML with the use security switch inside. So at this point, the Jenkins main configuration file has been removed from the Jenkins home directory by an unauthenticated user. All right, if you recall, the user module function getById we saw before was called with username as a parameter and another including parameter, which was set to true. That parameter we later found was called create, and it seemed like we could create new users in Jenkins Java cache, even though we were not authenticated to Jenkins. As we saw, the actual authentication check is performed a few lines afterwards. We also remember the funny usernames in our Shodan scan, the root username that we saw before. Here, we see the getById function called with create set to true, which in turn calls get or create here, which eventually reaches this line here. And this line checks if either create is true or config file exists, and if, as in our case, the create parameter is true, the code would simply create a new user with the ID we supplied, again, before the caller is authenticated. Let's now see another demo. Okay, we are now preparing a new base 64 basic authentication string
with username attacker. And now sending that base64 string, again, there's no need for a password because we pre-authenticated, to the Jenkins master using curl. Right here. Good. So, although we get an error here of invalid password, the user attacker somehow got himself into the user's list of Jenkins, the people's list, as we're going to see now. We're going to click the people's list here, and we'll see our attacker user that we just used, although pre-authenticated, now inside the users list of Jenkins. Now each user takes a certain amount of space in the Java virtual machine memory, and if the users have long names, the amount of space may be increased. By using the same curl command with very long usernames, we were able to crash the Java virtual machine due to low memory and force the Jenkins admin to restart the Jenkins server upon our will. Now, we've seen how the Jenkins main config XML file, a file containing the most important Jenkins security configurations, was moved from the Jenkins home directory to a new directory, effectively removing it, and how we were able to crash the Java virtual machine by filling up its memory with new users. So when Jenkins is restarted, it will be running in security disabled mode. This mode requires no authentication and considers any actor with simply access to the Jenkins master as an administrator. At this point, a sophisticated attacker can further exploit this situation to become stealthier. By reading the config file from the Jenkins home users $002E, $002E directory and making necessary changes to the files on the Jenkins file system, such as adding a new admin user or reading and decrypting the admin's API token, our attacker can copy the previously moved config XML file back to its original place. By doing that quickly enough and at the right time, the Jenkins master would be returned to its original security configurations, and nobody would notice the fact that the Jenkins master reverted to its legacy default, that is, security disabled, for a short while. This would be extremely dangerous for an organization, as it would make the entire attack on the network virtually undetectable. Good. So we are logging in as admin at first to see all the registered usernames in the people's page. Notice that there is no attacker username anywhere here. Now logging out. So this is the Jenkins master's IP, ends with 142. Let's see all the XML files under the Jenkins home directory. The first file here is the Jenkins config XML file, the main configuration file. Here is a small application we wrote to perform the systematic exploitation of the two CVEs we discussed earlier. So after we input the Jenkins IP and press the inject button on our little app, the application would send the username curl to remove the config XML file, and then start bombarding the Jenkins master with new users, all until Jenkins collapses. Here, we're looking into to see if we have a config XML file in the Jenkins directory. Naturally, we don't at this point. So we are now bombarding Jenkins with new users at this point. And we are waiting for the master to crash, for the Jenkins master. So at this point, you can see that Jenkins seems to be down. Okay, it's not responding anymore, and actually waits for the admin to restart it. So our little app now says that the server looks down, and it is waiting for the admin to restart it. Let's have a look at the Jenkins log file. It seems that the reason for Jenkins to be down is an out-of-memory error. This looks okay. So the admin now restarts the Jenkins process. And Jenkins now says that it is getting ready to work. Now, our little app notices that. And during this time, our app will inject a new admin user called attacker into Jenkins, since it is running in security disabled mode. And that's it. A new admin user is introduced, and the Jenkins master security switch is on again. So nobody would ever notice that we inserted our new user, admin user, into the system. Well, that's it. Thank you very much for being part of our journey.